Okay, good morning or good afternoon, class. This lecture, we will talk about what is the course, what is biopharmaceutics, and pharmacokinetics. I will be your instructor, Aaron Kobeng, a licensed pharmacist throughout this course. So, what is this course? It is divided into two subjects, namely biopharmaceutics and pharmacokinetics. Both of these drugs or both of these subjects relate to how the drug is being treated by the body. Biopharmaceutics examines the interrelationship of the physicochemical properties of the drug, the dosage form, the route of administration, and the rate and extent of systemic absorption. Biopharmaceutics also examines the related factors on how the drug is being taken up and removed by the body. So we are going to discuss the physicochemical properties of the drug, how the dosage form affects biopharmaceutics, and how the route and absorption affects our drug design. So biopharmaceutics provides a scientific basis for drug design and drug product development. Biopharmaceutics is centered on designing and developing a drug for it to be effective in a biologic medium. So biopharmaceutics, the main goal of biopharmaceutics is to make a good drug that is expected to give an effect towards the body. Pharmacology, on the other hand, is the heart of the pharmacy program. Pharmacology is the branch of medicine and biology concerned with the study of drug action. It is the study of the interactions that occur between a living organism and the chemicals that affect normal or abnormal biochemical function. Pharmacology is a broad field of medical science that can be further divided into parts. Pharmacology can primarily be divided into two main areas, namely your pharmacokinetics and your pharmacodynamics. Examples of other fields of pharmacology is your toxicology, toxicokinetics, toxicodynamics, pharmacogenetics, and your pharmacoepidemiology. Pharmacodynamics is broadly defined as the biochemical and physiological study of drug effects. It is the study of how the drug can exert its effect onto a biological specimen. The interaction of a drug molecule with a receptor causes a pharmacologic response. It is the study on what the drug does to the body. So, in basic terms, what the drug does to the body is your pharmacodynamics. You're already studying pharmacodynamics in your pharmacology class. Pharmacokinetics, on the other hand, is the second half of our course. This branch of pharmacology is dedicated to determining the fate of substances administered externally to a living organism. It primarily deals with the Ladmer processes of the body. So Ladmer is your liberation, absorption, distribution, metabolism, excretion, and response. We will be tackling all these phases in our course. Clinical pharmacokinetics is the applied This is the application of pharmacokinetic methods to drug therapy. The main process of therapeutic drug monitoring, or your TDM, is very important for potent drugs such as those with a narrow therapeutic range. So therapeutic range, or your therapeutic window, it is the concentration range between the MEC and the MTC. Okay, so what is MEC and MTC? MEC is the minimum effective concentration. MTC is the minimum toxic concentration. When we say minimum effective concentration, it is the plasma level concentration needed to exert an effect. Okay, minimum. Meaning if the plasma level does not reach this concentration, there will be no effect. MTC, on the other hand, is the minimum to exert a toxic effect. Okay, it is the minimum concentration to exert a toxic effect. So ideally, we want the therapeutic range or we want the plasma level concentration of a drug to be in between the therapeutic range or the therapeutic window. Samples of drugs which has a small therapeutic window, your warfarin, digoxin, phenytoin, and your tacrolimus. Drug exposure refers to the dose and various measures of acute or integrated drug concentrations in plasma and other biological fluids. Drug response, on the other hand, refers to a direct measure of the pharmacologic effect of the drug. Responses include a broad range of endpoints or biomarkers. Basically, response is something that is observable or measurable. For example, you have an antihypertensive. Okay, so if you give this drug, what would you measure? You would measure your blood pressure. Okay, if the blood pressure goes down, this is your endpoint or your biomarker. Okay, if you give an anti-hyperlipidemic, you will be measuring your lipid concentrations. Okay, HDL, LDL, VLDL. Okay. When we say biomarkers, on the other hand, or another term for biomarkers is the clinical effect, anti-asthma. You're going to measure or observe the amounts of asthma attacks. Okay, is the amount of asthma attacks decreasing or increasing? Okay, so what you have on the slide now is the plasma level versus time curve. Okay, you should listen well since this curve is something you will encounter throughout the course. Okay, so the plasma level versus time curve is a curve or a graph which compares plasma level versus time. The time is usually placed in the bottom, while the plasma concentration is placed on the left side of the graph. You're going to plot the plasma level concentration per unit time if the data is available. And you're going to put the best fit line in this data. This is usually a curve because once you administer the drug, it will undergo elimination processes. So do not expect a linear line. Okay, it is always going down. Okay, so let's talk about the parts. As you can see, there are different colors of the graph. Okay, and there are dotted lines along the graph. The first dotted line you will see, this is your MEC. The second dotted line, this is your MTC, or your minimum toxic concentration. So as we discussed earlier, the therapeutic window lies between the MEC and the MTC. Remember the definition of MEC? It is the minimum concentration required to elicit a response. So meaning, if your concentration does not reach the MEC, it is subtherapeutic. It does not yield a pharmacologic response because it did not meet the minimum required concentration. Okay, if your blood concentration or plasma concentration is beyond the MEC, you will now experience a pharmacologic effect. Okay, now next point is your MTC. If your plasma level concentration goes above the MTC, you will now experience toxicity. Okay, so anything below the MTC is safe. Anything above the MTC will exhibit toxicity. Now, ideally, we want to keep our plasma level concentration within the therapeutic window. it is in a concentration that yields a pharmacologic effect but does not yield a toxic effect. Am I clear? Okay. Other parts of the graph is the peak of effect. The peak of effect is usually the point of highest concentration because we tend to relate plasma level concentration with its effect. The higher the concentration, the larger its effect. And the duration of action here is the amount of time that the plasma level concentration is above the MEC. Okay, so meaning this point here is it does not still elicit an effect, and the points after this one are also subtherapeutic or there is no effect. So only this and this, the time between these 2 points is the duration of action. It is the time or the amount of time in which the plasma level concentration is above the MEC. Okay? Now we also have another term, which is your onset time. This is your onset time here. Onset time. It is the time after administration before it reaches your MEC. Okay? So please take note that drugs when given to the body does not yield immediate effects. Usually, following normal conditions, an orally administered drug will take at least 15 to 45 minutes to exert its effect. Okay? So let's move on with the last part of our lecture. Toxicokinetics and toxicology. It is the application of the pharmacokinetic principles to the design, conduct, and interpretation of drug safety evaluation studies. Take note, we are not studying poisons and toxicology to develop better poisons. We should look at toxicology as a subset of pharmacology in which it is needed to determine safety of our drugs. Since all drugs have a toxic effect, toxicology examines both poisons and drugs in terms of their safety. So toxicokinetic data aid in the interpretation of toxicological findings in animals and extrapolation of the resulting data to humans. Toxicokinetic studies are performed in animals during preclinical drug development. So toxicology is a very important part of the drug development process, especially when determining safety. Before we test it in humans, we should test it in animals first. Okay, so that is the end of our lecture. I hope you learned something today, and please take time to read the notes that will be posted in your LMS. The PowerPoint presentation will also be posted in your LMS.